Indiana University East, Isotopes and Mass Numbers. So, as you may recall, we have said before that protons and neutrons reside in the nucleus, while electrons buzz around outside of the nucleus. We also said that the nucleus is at the center and is a very small part of the atom. What we want to do now is to write down some numbers that gives us a handle on the composition of a nucleus. And there's two things we want to know. We have the number of protons. That gives us a charge on the nucleus, so we know that, and that's known as the atomic number, which we give the symbol Z. In addition, we can determine the mass of an atom, which is basically the mass of the nucleus, because the electrons have very little mass, and we know that protons and neutrons have about the same mass, so we state this as a mass number, which we give the symbol A, and that is our number of protons plus number of neutrons. So, to take an example, carbon-13 here has a mass number of 13, so the 13 here is the mass number, and because it's carbon, if you look at the periodic table, which lists elements in order of atomic number, the atomic number here is 6. Therefore, the number of protons is equal to 6. Now, number of protons plus the number of neutrons is equal to 13. And so if I subtract 6 from both sides of this equation, the number of neutrons is equal to 13 minus 6, which is 7. So a carbon-13 nucleus contains 6 protons and 7 neutrons. Now, so far so good. An element is defined by the number of protons there are. However, if I have the same number of protons but a different number of neutrons, I can still have it. Chemically, it will be the same, so we call them isotopes. Okay, so let's take a look at hydrogen. So hydrogen normally is hydrogen 1, so we have 1 proton only, and that is what we normally see. We also can have, if we add a neutron to it, it's still hydrogen, but now we give it a special name called deuterium, but it's basically, it is an isotope of hydrogen, and it has 1 proton and 1 neutron. And tritium, which is a lot rarer and it's radioactive, contains 1 proton and 2 neutrons. You now see how there's 2 neutrons in addition to the proton. All of these are isotopes of hydrogen. Chemically speaking, they all have the same properties. However, in nuclear physics, we expect them to have different properties because the nuclear composition is different. But we want a shorthand to do this. We don't want to draw it every time. So this is our shorthand. Okay, this symbol here is our shorthand. The big X here is the element symbol, the 1, 2, or 3 letter symbol that denotes a particular element. We also write down the mass number up here, and we write down the atomic number here. So for example, if we have 10 protons and 10 neutrons, then our atomic number is 10, because that's the number of protons. And if you look at the periodic table, it is neon. Okay, the atomic number, no, sorry, the mass number is the number of protons, 10, plus the number of neutrons, 10, which is 20. So we put 20, 10, neon. Now, one shorthand we can use sometimes is, this is really redundant because if we have neon, we know that there are 10 protons because that is our atomic number. So we can just write 20 Ne. Now, in terms of how we say this or write it out, sometimes what we do is we write it as neon 20. Like we did with carbon 13, we say what the element is, hyphen, mass number. Because we use the mass number to distinguish between different isotopes.